Look at all this. I'm embarking on a journey to do some more actual, real, honest-to-goodness iPerf testing with Wi-Fi 7 devices. If you don't know what that is, don't worry. That means actual, real-world testing, not just, let's unbox it and take a look at it. We're at a spot where these wireless devices can deliver greater speeds than the 2.5 gig Ethernet port on your motherboard. I think that's a crime against humanity. Wired should always be faster than wireless. Okay, to me, that says that our wired devices should be well beyond 10 gigabit at this point. We're overdue for ubiquitous fiber optic connections in our wired connections. But I want to get the lowdown on Wi-Fi 7 and where it stands, because Wi-Fi 7 is kind of new, but we still see a lot of Wi-Fi 6 devices in the market, like our expert Wi-Fi devices. I'm not going to focus on these today. This is just more sort of an interesting thing that happened that I'm going to talk about. I actually reached out to ASUS to ask about Wi-Fi 7, and they sent this, the RT-BE96U, but then also those. And this is tri-band, tri-mode, whatever you want to call it. But it's Wi-Fi 6E. We're going to come back to the expert Wi-Fi in another video. For now, I just want to focus on the RT-BE96U, the BE19000 tri-band high-performance router. Look at this. In the box, you get this giant, weird spider monster thing, and it's got lots of breather holes. There's a manual and some installation stuff that you can read, and a 65-watt power brick, and a single Cat6e cable. And that's it. It's a premium unboxing experience. Dual 10 gig interfaces. You got 4 1 gig ports, and I was kind of hoping the 1 gig ports would be 2.5 gig, but no, they're 1 gig. And then you got 2 10 gig ports, one here and one over here, and 2 USB, one 5 gigabit and one USB 2.0. And you can actually connect an Android phone directly to that, or a Wi-Fi 3G, 4G dongle, and use that as a backup connection as well. But you can also use a USB hard drive, file server that works, USB printer. Think laser printer or business class printer for turning this into a print server, not the standard issue demon-possessed inkjet printer. Those are terrible. No, friends don't let friends inkjet print. It's a router as big as your head. It's got 2 buttons, a Wi-Fi protected setup, and an LED, and also a mechanical rocker power switch. ASUS. When would you ever hit that intentionally? Reboot your router? No. Devices of this class, you don't reboot them. They're just always on. You don't need a power switch. You really don't. That's only there for you to accidentally hit it and then be angry as you wait for the device to reboot. And that design decision is common to the other ASUS wireless devices. I don't get it. I mean, if somebody, I don't get it. Why would you have a power switch? Okay, that's cool. I mean, that's like somebody expecting a crank start handle on their fuel injection internal combustion vehicle, right? I mean, okay, I love the fact that if you don't use this as a router, you effectively get dual 10 gig ports. Yeah, in non-router mode, you can use this just like an access point, and then you have 2 10 gig ports plus 4 1 gig ports, which is pretty awesome, plus all the USB. Now, internally, ASUS is doing all this in just 2 gigs of RAM and 256 megabytes of flash. We'll come back to that. That'll be important. For the first order evaluation, does it do what it says it does on the box? By and large, yes. Wi-Fi 7 is very impressive as it is implemented in this platform, but there are some things where it gets a little fuzzy around the edges when we talk about the software stack. Wi-Fi 7 is tri-band. That's 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. That's what Wi-Fi 7 means. You also see this thing called channel width. The channel width is 320 megahertz wide. This can be trouble in cities or other areas where there's a lot of other devices that are sharing those parts of the spectrum, especially 5 and 6 gigahertz, because 2.4 gigahertz is almost exclusively for older and slower devices. And in the speed tests, 2.4 gigahertz just doesn't really matter. Basically, when we talk about speed tests and speed testing Wi-Fi, we're testing inside a 30-foot by 100-foot Faraday cage, more or less. So it's like a best-case scenario. And the out-of-the-box setup for this is a breeze. Even if your ISP doesn't do DHCP and your ISP doesn't make it easy on you, all the weirdo edge cases ASUS handles well in their software. Fixed MAC address or known MAC address to your ISP, static IP setup, a lot of other variables like that can make life difficult. ASUS handles really well. I was really expecting all the aspects of the software to be a lot worse than they actually are. It's fast, responsive, it's pretty well documented, it's easy to get more help with the links to stuff on the web. ASUS has got pretty good write-ups steps and how-tos for common things that you want to do. And that reminds me, part of the reason that I'm doing this, do you know the story and the history of OpenWRT running your own custom software, your own firmware on a router? This was on ancient Linksys wireless access points and wireless routers. You could unlock the radios, you could unlock the firmware, you could do all kinds of stuff that Linksys never intended with their hardware. And I learned so much. And ASUS is offering a lot of the same kind of stuff here that I sort of felt was magical way back in the day. So it's a little bit of nostalgia here. Can the big guns in Wi-Fi 7 actually deliver the functionality? And what if we go off script and install our own firmware? Well, we're going to have to wait to another video if we go custom firmware. I don't even know if that's a thing with this particular model, but it is a thing on some ASUS models of router. I'm not sure. It is because of that past pedigree and the OpenWRT thing that we have devices like this that are as open as they are. But even as open as it is, does it have the performance goods? Let's dive into the iPerf numbers. Okay, very impressive. Over 3 gigabit is easily doable with most contemporary Wi-Fi 7 hardware and chipsets. It's working really well. Most stuff can only do 2 gigabit, so the fact that this is doing 3 gigabit out of the box without me doing anything special or tuning or anything is fantastic. Also, check out our CPU utilization here, less than 8%. And this is in a worst case scenario. What's happening is that the chipset is doing most of the heavy lifting here. So the CPU in this thing, it's 4 cores, doesn't really have to do a lot when we're just talking about shuffling packets around. Now, Wi-Fi 6E can be configured to that same 320 megahertz channel width, and you should try that in your existing setup before you upgrade. You generally do not get the 6 gigahertz band from Wi-Fi 6E devices, but I have actually seen a couple of firmware upgrades that seem to enable Wi-Fi, the 6 gigahertz Wi-Fi channel on what was formerly Wi-Fi 6E devices. Don't quote me on that, I'm not 100% sure, but the 320 megahertz channel width thing is definitely worth the upgrade if you get that on the 5 gigahertz band. And more importantly, running the test here, running an SMB file copy from a server on the internet, plus an internet speed test, plus iPerf. I mean, yeah, we dropped down to about 80 megabytes per second, but we can sustain 110 megabytes per second for most of the file transfer. And even juggling all three of these things, it doesn't ever drop below 80 megabytes per second. An important thing with these Wi-Fi devices, because most other Wi-Fi devices have gotten so crappy that they crap out after 20 or 30 seconds. Even in your laptop's Wi-Fi may not have adequate cooling, so it can't sustain. What we do for testing here is to copy a 50 gigabyte file over the Wi-Fi a couple of times to see if we see any kind of throttling. Sometimes you don't get any report of an error other than just it's mysteriously slower. And this is common on things that are not truly commercial grade. So I'm happy to report that everything here was able to sustain. Now, I mentioned the temperatures. If you want to get an idea for what we're looking for with the FLIR, check out this FLIR footage. If you've been following the channel for a long time, you know that a long time ago we covered, say, Ubiquity's access point when Wi-Fi 6, well, Wi-Fi 5 really, and Wi-Fi 6 was sort of a new thing, and packing in a lot of radios in an access point was a new thing. And in very short order, those access points would turn yellow, discoloration from heat. So now we check everything with a FLIR just to see how it does after torture tests. Now, some of you are already screeching from your couch and or chair and or floor, wherever you're watching this video, about the 3 gigabit remark. Because you know that a single connection on a single radio is not going to deliver 3 gigabit. It makes multiple connections. And when we're running iPerf and we've got multiple connections open, the aggregate is 3 gigabit. But coming in 2024, the second half, Windows will have native support for this, because the support in individual device drivers and on individual platforms has been very varied and very, very hit or miss in terms of your experience. I mean, we've got our wireless access point here, our Framework laptop MediaTek, and a Minis Forum tablet, and a whole bunch of other wireless devices. And depending on the software loadout and a whole bunch of other things, you may not be able to take advantage of multiple connections being automatically aggregated into a single connection. That's MLO. So ASUS talks about that technology on their website, and they're ahead of the game when it comes to that technology because it's already here, it's ready to go. But Windows is lagging behind. But 24H2 version of Windows 11 should have that built in, so you shouldn't need to rely necessarily on janky third-party drivers. But the hardware support for it in the ASUS router seems to be pretty good. iPerf tests, yeah, 50 gigabytes at a time, and we will fail a device if the device overheats or it just silently throttles. Like we're cruising along at, 2-3 gigabit, that's like 200 megabytes per second, and then it just mysteriously backs off to like 50 megabit or something much slower, then there's throttling happening somewhere. Something went wrong catastrophically, and we would have to say this doesn't pass. But I'm happy to report the ASUS passes. Another thing that you have to be careful about is when you go off script with the reviewer guide, because these devices usually come with a reviewer guide, and this did come with a reviewer guide, but largely I skipped the reviewer guide. It's just how we roll. The encryption can make an impact more than most people realize. So there's WPA2, WPA3 hybrid, and WPA3 standalone. And most of the time we're talking about the personal versions of those. There's also enterprise versions of those sets of encryption. And sometimes most of the testing would be like on a lesser grade of encryption. So you run that and everything runs fine. But then if you switch it up to WPA3, then you have issues. Some older devices don't support WPA3 properly, and so you end up running WPA2. And some devices support WPA2, WPA3 hybrid, or some access points will support offering that. In this case, we did all of our testing with WPA3 unless it was otherwise indicated, and it's probably going to be a part of our standard setup. I'm happy to report the 4-core CPU and 2 gigs of RAM wasn't much of a bottleneck in any of these scenarios, which means that the chipset and the software is handling that really well. So for our testing, shuttling files back and forth and all the parameters there, the type of encryption really didn't seem to significantly impact the throughput, latency, responsiveness, etc. Now the web GUI is pretty well put together, and it's pretty impressive that they were able to do this in just 256 megabytes of flash and 2 gigabytes of memory. Of course, that means that your customization options here are really limited. You want to run Pi-hole on this thing natively? 2 gigs of RAM. Like you're not going to be doing anything. In fact, Pi-hole is funny because it came up so often. It's actually in ASUS's frequently asked questions. And there is a guide that ASUS offers to reconfigure this thing to be able to get to a Pi-hole server running elsewhere on your network. So if you're running a file server or something you can run Docker on and that's running Pi-hole, you can tell this thing, hey, Pi-hole's running on the network. Here's how you configure it. And then all of the DNS and ad filtering traffic for that will run through Pi-hole on the network. So it's not technically running on the ASUS, but the ASUS is redirecting DNS traffic to something else on your network to say, hey, this thing is handling that kind of filtering, which is pretty cool that ASUS wrote a how-to for that. But because there's not like, a computer in here or it's 2 gigs of memory and 256 megs of storage, not going to be able to do much with that natively on here. Now, while you can't run Pi-hole, you can use this thing as a file server. You can plug a USB hard drive into your USB port, and that actually does work really well, shockingly well. It supports Samba, which makes it show up like a Windows file share. It also supports Mac, so you can do that. And that it works as well as it does in just the 2 gigs of memory. It works surprisingly well. Now, let's talk for a second about network address translation. 2 gigs of memory, this works out to about 3,000 state entries in the network address translation table. High-end users normally would only have around, let's say, 100, 150 NAT states across their entire machine. Basically, this is the router keeping track of connections that your computer has open. Because you're on this channel and you're watching this video and you've made it this far, chances are you're more than like 200 to 300 states per machine that you're using heavily. If you're torrenting, it's like 500, 600 states, 700 states. This thing can manage about 2,000 states before it starts closing the states that have less connections open, or at least that seems to be the case in my testing. It's not fully conclusive, but I would like to have seen more NAT states. If you're running a completely custom router, something that's based on a PC, it can manage millions of states. A lot of the time, your modem from your ISP has trouble managing that many states. When doing these kinds of tests, nobody ever talks about how many NAT states can the thing handle, because it's sort of a pain to test. You basically have to do like a simulated ISP kind of a thing. But how you know you're having problems with your NAT states, one of the ways that manifests is VoIP traffic or even sometimes Discord traffic, because VoIP traffic will maintain an open connection, but it's not really sending a lot of data. There's not a lot of packets going across that connection. And if your connection stays open, but somebody suddenly can't hear you on a VoIP connection, that may be a sign that your router has said, I can't maintain the table of who was talking to whom. There's too many entries in this table. I'm going to close the ones that aren't getting a lot of traffic. And so the computers that were talking to each other don't know that the connection is closed, but the router physically can't keep track of that. This does much better than most, definitely better than anything you would get from your ISP. But I'm used to working with really high-end and commercial grade stuff. Maybe I should expect more, but at the same time, 2 gigabytes of memory, I don't know. That's just my way of saying it's good, but ASUS, you could do better. Maybe it's better on the gaming version of this. But it does have gaming features that work really well in terms of prioritization. Now, if you don't use this as a router, if you just use it as an access point, the NAT state table thing doesn't even matter. It won't apply to you. And something like 2,000 to 3,000 open states at a time is nothing to be ashamed of. That's pretty good. Do you really have 20 people on your 10 gigabit connection, 20 like super power users? Probably not. But if you're like me, it's good to know. This is a pretty good router in its price class. And I would go out on a limb and say that the Wi-Fi 7 implementation is about the best thing going for this particular piece of kit. If you don't use this device as a router, then it's going to function really well as a small switch with 2 10 gig ports, and you've got 1 gig ports, and you've got other functionality here. Oh, this device can also be a VPN client or even a VPN server, meaning that you can tunnel your VPN traffic to another, VPN system out on the internet. It has some features for parental filtering, but the number of rules supported is very limited. And honestly, you'll be better off using different software if you need parental control. ASUS often partners with Trend Micro for malware filtering and malware protection at the router level. And this one is no different. I mean, under the hood, it's called AI Protection Pro now. And the bullet points are router security assignment for malicious site blocking and two-way intrusion protection system and infected device prevention and blocking. And this is more bullet points on the product page than something that you'd actually use. It's not a new feature for this product, and near as I can tell, it doesn't really actually do much. I mean, I could download malware just fine from GitHub, and only certain types of malware would be detected and blocked. If I try to go to awfulmalware.ru, yeah, that was blocked, but it's seemingly some type of DNS block, and I don't know. Don't quote me on that. I think that there's better security products if you're into that. This router can also participate in an AI mesh, ASUS's mesh Wi-Fi experience, which is surprisingly good for what it is, but it doesn't rise to the level of what you get from mesh functionality for multi-access point solutions from Meraki, Ruckus, Juniper, etc. The guest network functionality also on this is okay. You can do time-limited guest connections, but doesn't really support a lot beyond that. It's like, I would love to have separate VLANs and, get into really fun stuff like that. No, this device doesn't do that. I really do like the USB dual WAN feature more than I thought I would, because if your internet is down and you don't have like a backup dedicated internet connection, you can just use your cell phone to get all your network devices back on the internet in a pinch. That's actually really cool, and it works as advertised. It does actually support link aggregation as well. So if you wanted to do link aggregation across your 1 gig ports, you could. But this is not something that I would actually use on this class of hardware. But it does actually work as advertised. And plugging in the USB hard drive was surprisingly functional. I don't really have anything that I can fault it for there. It is possible to do stuff with the USB hard drive and really trigger high CPU utilization while you're doing other things. But generally, I couldn't cause a problem with that. ASUS has taken a major step in the right direction, I think, with this hardware, and it's got the goods in terms of the Wi-Fi 7 radio. The price point is around $700. It's a little tough to unpack the price, because if you look at building a similar system, like say with Ubiquiti, in the time that I'm making this video, you probably have to go with a U7 Pro, but you can't just go with one U7 Pro. You'd have to go with 2 to get a similar device density support as this thing. And each one of those is only going to support 2.5 gigs, so you're only going to real world get about 2 gigs even from Wi-Fi 7 devices, whereas this thing is doing over 3. And you would also have to get a PoE switch, so you're basically already at cost parity. The stability of the firmware on this has also improved dramatically since earlier in the year, in December. One of the recurring issues with this is that devices would drop down to the 2.4 gigahertz band. And newer Wi-Fi seems to have addressed a lot of that, but the bug fixes for that, especially around MediaTek's chipset, I've got a couple of AMD Advantage laptops with MediaTek, and they would mysteriously fall to 2.4 gigahertz even when I had disabled power management, even when I had taken steps to just say, no, don't use the 2.4 gigahertz. And from packet captures, it seemed like this thing was steering those devices to 2.4 gigahertz. I also set up a similar Wi-Fi 7 set up on other hardware and didn't experience the same band steering. So doing things like a simulated video call at 1080p, it's like, oh, it's obviously entering a power saving state. I don't think so, but it would still roam to the 2.4 gigahertz band, which is really, really odd. But the firmware update earlier this year seemed to really improve that. And if you've got an internet connection in the 5 to 10 gig range and you really want to take full advantage of it and have good Wi-Fi coverage and be able to do the mesh thing, this really isn't a bad starting point. And it costs less than Eero, Orbi, and some of the other solutions. And some ISPs have even taken to bundling those solutions because people know that the stuff they get from their ISP is basically trash. So, but this is truly Wi-Fi 7. It is truly tri-band. It is truly 2.4, 5, and 6 gigahertz. So that's really nice to see. There's not a ton of Wi-Fi 7 devices out there, which is surprising. It works great with cell phones and everything else like that. I don't think with a cell phone you need a multi-gigabit connection, but it sure is nice on laptops, especially when you're moving files back and forth across the Wi-Fi server, not having to plug in. If you are using wireless on your desktop, I'm so sorry. If you just can't get a wire there, okay. But being able to reliably do 2.5 gigabit and better speeds via Wi-Fi, very, very impressive. Now, wired still wins on latency. We're talking about two different aspects of speed here. How fast can you copy a file and what's the latency? Wi-Fi latency is still higher than you would get on a wired connection. So if you're super latency sensitive, you're still better off on a wired connection. But we're talking about a delta of, less than 10 milliseconds, but that can still be a lot. In the beginning, I had evocations of, the Linksys custom firmware flashing. It's like, it looks like it's got the goods on paper, dual 2.5 gig and everything else, but I have not visited the custom firmware thing. So if you're into custom firmware, or you know somebody that does custom firmware, or there's some resources that I can read, hit me up in the Level 1 forums. Let's start a thread. Let's take it to the next level. Although, with 2 gigs of memory and 256 megs of flash, don't know how much more we can really get out of the platform in terms of customizing. Maybe we should leave well enough alone, because it does what it says it does well enough. I'm of two minds about this product. It's also interesting that some of the other ASUS Expert Wi-Fi products have 4 gigs of memory, like the business class stuff. It's interesting, but that'll have to wait for another video. I'm Wendell, Level 1. I'm signing out, and you can find me in the Level 1 forums.